Flack math! Give me some math and I'll give you some flack. Flack math!
So when y is by itself, it is officially in slope-intercept form. So when y is by itself, you're given the slope, which we'll talk about in a second, and you're given the y-axis intercept, okay? So in this case, the slope, which is what m is because of all the m's in the word slope, and you're given the y-axis intercept because of, it's called b, obviously, because of all the b's in y-axis intercept. So we just call it y-intercept. So the y-axis intercept is exactly what it sounds like. It's where the line crosses the y-axis, okay? So if this is the y-axis, this is the x-axis, it crosses right there, okay? So that's the y-axis intercept in this particular line, okay? The slope is basically rise over run. So that's how you measure how the steepness of something. For example, I have a friend in a wheelchair, and he was telling me that all the wheelchair ramps that are made have to be a 1/12 slope. So 1/12 slope. That means for every foot high they go, they need 12 feet of distance to go a foot. So it's like, here's 12 feet. It can only go up a foot for every 12 feet. So that way it's easier for a wheelchair, someone to push themselves up a wheelchair. That's why you see like these ramps going, like these switchbacks going back and forth, because they have to keep it at a 1/12 slope. So rise over run. So in this case, our equation here is y equals 2/3 x minus 5. So this 2/3 is our slope. So that means rise is 2 and run is 3. So it's nice when it's a fraction because it tells you exactly how much to rise, 2, and how much to run, 3. And then our y-axis intercept is not 5, but -5. So see how that crosses that -5. And then from -5, it goes up 2, blip, blip, and over 3, blip, blip, blip. Okay, up 2, blip, blip, over 3, blip, blip, blip. So we don't have to plot points anymore. We can just put it in this secret formula. So when y is by itself, that's called slope-intercept form, but the other side reveals all the secrets of the line. It tells you where to start, and then it tells you which direction to go, okay? So it's not enough to just tell you a slope, like, yeah, draw the line with a 2/3 slope. Well, you don't know where to put that line. I mean, you could draw this same line anywhere, right? And it has the same slope, but it doesn't help you unless you know where to draw it. And so this y-axis intercept tells us where to draw it right there. Okay, so we know how to draw a 2/3 slope, up 2 over 3, up 2 over 3. Okay, and then we're done. All right, and it doesn't help you just to give you the y-axis intercept, because there are multiple lines that could go through this. Actually, there's an infinite number of lines that go through this, right? But there's only one with a 2/3 slope. So you need both. You need the slope and you need a point. Okay, so let's backtrack just a little bit. The beginning of this chapter talks about the easy ones. Well, what they say are the easy ones. Okay, so like the easy equations are when you have like a y equals just this. So forget about slope-intercept form for a second and just look at these equations. So let's draw another graph here. So let's look at y equals 2. All right. So there's no slope. There's just an intercept. So y equals 2 looks like this. So on the line y equals 2, everywhere on this line, y equals 2. So look at this point here. This is 0, 2. This is 1, 2. This is 2, comma 2. This is 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, all the way to infinity, comma 2. Over here, negative 1, 2, negative 2, 2, negative 3, comma 2, negative 4, comma 2, negative 5, comma 2, all the way to negative infinity, comma 2. So when y equals something, that is a horizontal line, always. All right? Now, when x equals something, well, same thing. Let's say x equals negative 3. Well, what line can I draw where x equals negative 3 everywhere on that line? So that means negative 3 something. Could be anything, right? So that means this line right here is x equals negative 3, because everywhere on this line, it's negative 3, 2, negative 3, 0, negative 3, 1, negative 3, negative 1, negative 3, negative 2, negative 3, negative 3. Okay? So when x equals something, that is always a vertical line. Okay? So those are the easy ones. You don't have to put it in slope-intercept form or anything, because it's just like a variable equals something. All right. So when that's the case, it's either a vertical or horizontal line. There's no slope to it. Now, when you think about slope, this kind of makes sense, because this y value here, I could put it in slope-intercept form because there's no x's. So I could say y equals 0x plus 2. So it has a 0 slope. Well, that makes sense because look at this road here. It's flat. So there's no slope to this road. Okay, but it does cross at 2, so that's why that y has an x-axis or a y-axis intercept. Okay, so there's 0 slope. Now, when x equals something, this is not a slope. This is like a wall. All right, you can't drive your car on that. You would not want to drive your car on that. Okay, if you tried to drive your car on that, then you would become undefined. So we call this slope undefined, because if you calculate the rise over run on both of these, the rise over run here, it goes up 0 over 1, or up 0 over 2, or up 0 over infinity, right? But over here, if you calculate the rise over run, you are rising, but you're running 0. So remember, you have a value on top, like the slope here is like, you could pick any number, 3 over 0, or 4 over 0, or 5 over 0. What happens when you divide by 0? Undefined. So that's why we call this slope undefined, but this slope is 0. Okay? So those are the easy ones, but for some reason, they're harder to remember and harder to explain for sure. Okay, so let's try an example, and let's see if you guys can do this one here. So let's try to graph this equation. So we're going to graph y equals, where is it? 3x minus 5. Now, if you forget the whole magic of slope-intercept and all of that, you can still do this and get away with it, okay? You can still pick some x values and figure out what y's they produce and things like that. But we're going to try it our new way here. And then you can always check it by picking some values too. And that's what you should do on a test, right? You should try to graph it, slope-intercept, and then pick a few values and plug them into your equation and see if it works. Okay, so let's see. Y equals mx plus b is our slope-intercept, and it's already in slope-intercept form because y is by itself. So slope is whatever number is in front of the x, whatever number x is being multiplied by. So slope equals rise over run, right? Okay, well, that's a fraction. So how do you turn 3 into a fraction? Well, you have to put that over 1, right? So now it's a slope. Now you have your slope. So you're going to rise 3 and run 1, okay? All right, but where do you start from? Well, you start from your y-axis intercept, okay? So that's what your y-axis intercept is. So that's at -5. Same one as the last problem. So we're going to go down to our -5. 1, 2, 3, 4, 5. Okay, so this guy is right there. And then we're going to follow this direction. We're going to rise 3 and right 1. Okay, so a better way to say it is rise over right, because run, you don't know which direction, but you're going to go right 1. All right, so we're going to go rise 3, 1, 2, 3, and then over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. Okay, connect the dots and you're done. So you don't have to do it 3 times like I did. I could have just gone up 1, 2, 3, over 1, put some arrows on the end, call it good. Okay, that's it. All right, let's check it. So we know that one of our points is 0, -5. So let's plug in 0 for x and see if we get -5. 3 times 0 is 0, minus 5 is -5. Check. Another point is 1, 2, or -2, right? Let's plug in 1 for x and see if we get -2. 3 times 1 is 3, minus 5 is -2. Check. All right, here's another point. Looks like 3, 4. Let's see if 3, 4 works. 3 times 3 is 9, minus 5 is 4. Check, it works. Okay, so that was pretty easy. Everything, this slope, pretty easy. We had to like put it over 1 to calculate what our run was because we didn't see anything on the bottom. We just had one number. So let's try another one. Okay. Let's try example 3 here. Here's what example 3 says, and this is all in your book too, so you can look in your book if you want. So find the equation. Oh, no. Let's go back. Let's go back. Let's go back. Let's go back. Let's do. Let's try this. Y equals -1/2 x minus 2. Okay. All right. So what? Oh, my voice cracked. That's okay. I'm not going to be embarrassed. Just move on. They didn't notice. They didn't notice. I don't know if they're paying attention anyway. It's okay. Probably brushing their teeth or something because they woke up late. Just don't let it bother you. They're not going to notice. Move on. You're talking out loud. Shoot. Okay, here we go. This is our slope. This is our intercept. That's easy. All right, well, slope equals rise over run. But what's the difference here? There is a negative sign. So that means this is -1 over 2 or 1 over -2. It doesn't matter. You can put that negative on top or on the bottom. We usually put it on top. Okay, so -1 over 2. So that means I'm going to rise -1. What does it mean to rise -1? Well, probably exactly what you think. You're gonna go down instead of rise. You're gonna go down 1 instead of rise 1. So we're going to go rise -1, which basically is down 1. And then you're going to right 2. So you're going to go right 2. So then you're going to go down 1, right 2. Okay? I'm going to make this bigger. Keep going. Go bigger. Go big. Go home. All right. That looks good. Down 1, right 2. So where do we start? We start at this y-axis intercept. That's at a -2. So I'm going to go right there. Okay, so that goes right there. And then I'm going to go down 1, right 2. From here, I'm going to go down 1, right 2. Down 1, right 2. Down 1, right 2. See how I'm getting that slope? That looks good, right? So that's it. You can check it with some X's and Y's if you want, but that's going to work. Okay, now the next part is you going the opposite direction. So you have to decide what the equation of this line is. Okay, so let me draw an equation. So I'll draw a couple here, and we'll try to figure it out together. Okay. Okay, so I want to figure out the equation of this line. So the first thing you should do is let's just write our form with m and b. So mx plus b. So remember, this m stands for slope, and this b stands for y-intercept. So remember, the y-intercept is where it crosses the y-axis. So where does this line cross the y-axis? So it looks like right there. So y-intercept equals 3, positive 3. Okay. Now the slope, remember, equals rise over run. Okay. So now we have to pick 2 points that look like points, that look comfortable. Now you could pick any 2 points on this blue line anywhere, but let's pick the ones that look obvious to me. It looks like here's a point, and then if I go down a little farther, there's another point, there's another point, there's another point, there's another point. So let's see what it's doing. Well, first of all, if you were in a car and you were going left to right, so here's the car, not a very pretty car. So you're going this way and you're going to hit this road. Are you going to go down or up? It looks like you're going to go down, but you better buckle up because that's not safe. You don't want to go down that, especially in the snow. You will wreck and crash your car. Okay, so that's a down slope. So it's going to be negative. All right, so you can decide that now and then forget about it. So for example, I'm going to say negative something because that's going down. But if it looks like this, that car is going to go uphill, right? So, but it looks like it's going to go down. So, but let's just check to make sure. So I'm going to pick a couple points. Here's this point and this point. So how far down does it go? So you have to get from this house to this house, right? So don't cut through people's yards. That's rude, and they might call the cops, or you might get bitten by a dog. Okay, so let's go down 3, right? To get from this, you're going to go south 3, and then you're going to go right 2. Well, we know how to do that. Down 3 is negative 3, right 2. Okay, so what's our equation? Our equation is y equals slope x plus y-intercept, which is 3. That's not bad, right? So you're just looking for 2 things. You're looking for intercept and you're looking for slope. Okay. And you can, especially when you're given a nice graph and your math teacher isn't trying to draw it perfectly, it's easier to see. Okay. Let's try another line and see if you guys can do this. So try to do this before I do. So here's what the next line looks like, and I'll just draw it right on here. Maybe I'll get rid. No, I'll keep that. You know what? I'm gonna do something different here. This is gonna be great. You're gonna love it. You're gonna love it. Oh yeah. What is he doing? He's so smart. Can't even believe it. Okay, so there's a nice little line. See if you can draw an equation of that line, or write an equation of that line. So take a minute and try that. Okay, so I'm gonna stay green here. First thing I'm gonna do is I'm gonna start with my y equals mx plus b, and then I have to figure out the slope. Okay, well, let's see. Let's pick a couple points. Well, since we're picking points, let's figure out the y-intercept first. Okay, where does it cross the y-intercept? Right there. So it looks like that is -2. Okay, so there's one obvious point. All right, so then how, now this is all cloudy and whatever there. So maybe pick another couple of points over here or something. I don't know. Or maybe let's go from here to here. So let's go from this point to our y-intercept. So how much rise does it do and how much run does it, or right does it do? Rise over right. Okay. Well, to get from this house to this house, or if you want to go backwards, you can. You can go down 1, left 2. Okay, so it doesn't matter which direction you go, but I always go left to right because I'm from America, and that's what we do. We go from left to right. Okay, so we go up 1, and then we go right 2. So how do you say that in mathiness? That's +1, +2. Or I could have done, if I went from right to left, if I went from this point to this point, I could have gone down 1, left 2. Well, what's that in mathiness? -1 over -2. Well, what's -1 divided by -2? The negatives cancel and you get 1/2. So it doesn't matter which direction you go, but it's easier if you just go left to right. Okay, because if you go left to right, your run, your right, your bottom number will always be positive, and so it's just easier. Okay, so we figured out our slope, which is 1/2. We figured out our y-intercept, which is -2. So now let's put them in their places. So this is y equals 1/2 x plus -2 or -2, same thing, y equals 1/2 x minus 2. Okay, don't forget that x when you're a newbie doing slope intercept. you forget that x. So don't forget that x, okay? All right, that's it for that. Let's see here. Okay, I'm going to do a couple more things here. There's a what? So that's y-intercept. That's slope-intercept, right? So what happens when that's not the case? What happens when you're given? Here is example 5. We're going to move ahead here. Skip a little bit. We're going to graph this equation. Graph x minus 2y equals 4. Okay. Well, what happens when y is not by itself? Well, get y by itself. So this is not in slope-intercept form right now. This is actually called standard form, but we want to get it in slope-intercept form. So let's get y by itself. So first thing we have to do is get rid of the x. Or remember, the shortcut is to put x over here, we just have to make it negative. Okay, so we got negative 2y equals negative x plus 4. You could say 4 minus x, but remember slope-intercept form has the x first and then the constant. So let's keep it like that. Now we're going to divide by negative 2, divide everything by negative 2. So then you get y equals negative 1x divided by negative 2 is a positive 1/2 x. And then 4 divided by negative 2 is just a negative 2. So this is what our equation looks like in slope-intercept form. So that means this is our slope. So up 1, right 2. And this is our y-axis intercept, so negative 2. So let's draw our line here. Okay, so I'm starting at negative 2 right there. Then I'm going up 1 over 2, up 1 over 2, up 1 over 2. Draw the lines, boom. And that's it, okay? So if it's not in slope-intercept form, put it in slope-intercept form. And then it's easy. So and if you were going to go back to this, if you're like slope-intercept form sounds really weird, then you can still do it this way, but it's always better anyway to get one of the variables by itself. So if you get y by itself, you can still plug in values a lot easier here. It makes it just a lot easier. Okay, so get y by itself, and then it reveals all the secrets. Y equals slope times x plus y-intercept, so negative 2. All right, good. Let's move on to lesson 76. So lesson 76, we're going to talk about consecutive integers. So consecutive means like numbers right after each other, like 3, 4, 5, right? Or like negative 10, negative 9, negative 8. They just don't skip. So it's not like 3, 5, 7. But consecutive integers means the next integer. So the next integer after 3 is 4. The next integer after 4 is 5. So basically you add 1 every time, right? When you have consecutive integers, you're just adding 1 to get to the next one, okay? So for example, if I have my first consecutive integer is, let's call it n, all right? And if I say the second consecutive integer, you're just adding 1. So n plus 1. So if, for example, if n was 3, the next one would be 3 plus 1, which is 4. Make sense so far? So the third is going to be n plus, how do you get from 3 to 5? You add 2. And the fourth and so on. So you're just adding 1 every time. So you could think of this is n plus 1 plus, this is n plus 1 plus another 1. And this is n plus 1 plus another 1 plus another 1. Okay? But think of it like this. So this is what we're going to use to solve some puzzles here. Okay? So here is example 1 in my consecutive integers. So you're going to get a word problem that says find 3 consecutive integers such that, okay, such that, and here's the riddle. The sum of the first and third is 146. Okay, so we're going to translate that. So how do you say the sum of something? Well, that is an addition sign, right? And so remember, when you see the word sum, you see the word of, which does not mean multiplication, but then you see 2 things that will connect. Okay, so you're going to see the first, and then this word and connects is basically what now after the word and is the next thing you're adding or summing. Okay, so the first and the third. So how do you say the first? Well, the first is n, right? So we're going to put the first right there. So this is n, and then the third. How do you say the third? Well, the third is n plus 2. So see how this is the sum of the first and third. And then, of course, how do you say is 146 equals 146? So here's my equation. This is nice. This is just n plus 2 equals 146. So let's combine like terms. We're going to simplify the equation and solve. So n plus n is 2n plus 2 equals 146. So far, so good. Okay, so now how do we get n by itself? Well, let's follow the steps of our equation. There's no variables on both sides. So let's go to the next part where we subtract the constant from the variable side. So we get 2n equals 144, right? So now we're going to divide by variable's coefficient, divide by 2, divide by 2. So n equals 72. All right, well, let's test this in our word problem. The sum of the first and third, so n equals 72, but that's not the answer because the answer says find 3 consecutive integers. So if n is 72, that's the first one. So what are our 3? 72, 73, and 74. Okay, so let's see if this works in our riddle. The sum of the first and third is 146. Is that true? What's 72 plus 74? 146. It works. Okay, so this is our answer. Not this. I shouldn't have circled this. Okay, the answer is just 72, 73, and 74. Now, obviously, when you do this work on a test, I want to see this. I want to see that n equals 72. And some of you, a lot of you, will probably forget to write 72, 73, 74. You solved the equation, but you didn't answer the question. So if you do this, I probably won't count it wrong, but I will think a little less of you. But that's okay, because I already think highly of you. So if I think a little less, then it's not, you're still awesome. Okay? So let's try one. Let's try another one. Let's try example 2 here. All right, let's see if we can make the riddle a little bit more complicated because that one was a little easy. All right, here's example 2. Find 3 consecutive integers such that, all right, so this is usually how these things start. Find 3 consecutive integers such that, okay? So you can just ignore, I mean, you need to know that 3 consecutive integers, okay, well that means, let's see, let's draw Let's figure out what that means. That means the first is n, the second is n plus 1, and the third is n plus 2. Okay, such that, all right, now here's the riddle. Such that twice the sum of the first two integers is 2 less than 3 times the third. That's a riddle. Okay, so let's just do this one step at a time, one word at a time. Okay, so how do you say twice the sum of something? Well, twice does not mean exponent. Remember, if I'm twice your age, I'm not squaring your age, I'm multiplying it by 2. So I'm going to go 2 times the sum of something. And so the sum is usually, especially in this curriculum, it's just adding 2 things together. So see how I have 2 times elephant butt, okay? So when you see the word sum, draw an elephant butt. So twice the sum. So 2 times, I need these parentheses because I want to multiply whatever I get here times 2. Okay, so then the first 2, how do you say the sum of the first 2? The first 2 integers. Well, the first 2 are these guys right here. These are the first 2 integers. So that's just n, and then n plus 2, or n plus 1. These are the sum of the first 2 integers. Okay, and then how do we say is 2 less than? Ooh, is 2 less than? Well, that's is, but 2 less than, remember, is not 2 minus. This is a reverse. This is a reverse phrase. Oops. Whoa. Easy there, tiger. So I'm going to reverse that. So this is something minus 2. Okay? Well, what is that something? Well, this guy right here. 3 times, let's do a different color. 3 times the third. How do you say 3 times the third? 3 parenthesis n plus 2. Because this is 3 times, which is exactly what it sounds like. You're multiplying 3 times something. Well, what is that something? The third. Well, the third is this. N plus 2. So you need parentheses because otherwise it would just be 3n plus 2. So no, you don't want 3n plus 2. You want 3n plus 2. Okay? So make sure you put parentheses there. All right, now this is a little bit more complicated, but we know how to follow the steps of equations. So we're going to simplify and solve. So you can distribute right now. So we're going to get rid of parentheses first. So let's see, that's 2n plus 2n plus 2. You could have combined these first if you wanted to, but this works the same way. 3n plus 6 minus 2. All I did was distribute and got rid of parentheses. Next part of simplifying both sides is to combine like terms on both sides. So this is 4n plus 2 equals 3n plus 4. So these guys are like terms as well. Now we do have variables on both sides. So let's get rid of the smaller one. Get rid of 3n on both sides. So then you get n plus 2 equals 4. Get rid of that constant term on the variable side. N equals 2, and you don't have a coefficient, so this is your answer. Well, not your answer. This is the answer to your equation. So now what are our 3 consecutive integers? Well, if the first one is 2, then the next one's going to be 2 plus 1, the next one's going to be 2 plus 2. So our answer is 2, 3, and 4. Let's check it just to make sure. We'll plug it in, twice the sum of the first 2. Well, the sum of the first 2 is 5. So twice that sum would be 10. Is 2 less than 3 times the third? Well, 3 times 4 is 12. Is 10 2 less than 12? Yes, it is. Okay, awesome. So let's see here. that is another example. We could try one more. Let's just try one more and then we'll be done for the day, okay? So here is example 3. Let's see if you guys can do this on your own. And I'll give you just a minute to try it and then we'll come back here. So find 4 consecutive, find 4 consecutive integers such that, all right, and here's our riddle. 6 times the sum of the first and fourth is 26 less than 10 times the third. All right, take a minute and try that. So 6 times the sum of the first and fourth is 26 less than 10 times the third. So try that. I'm going to stop sharing for just for a second. So the most challenging part of this is just going to be finding your equation. But as long as you don't get overwhelmed by the craziness of it, if you just take phrase by phrase, we're good, okay? So how do you say 6 times the sum of the first and fourth? Okay, well, let's go 6 times the sum, so 6, print, and then elephant butt. The first, well, that's just n. And the fourth, okay, well, let's see if the first is n, and the second is n plus 1, the third is n plus 2, the fourth must be n plus 3. So here's the sum of the first and fourth. Okay, so this is 6 times the sum of the first and fourth. And then we've got this beautiful word is, which is our equal sign. And then we've got 26 less than 10 times the third. All right, 26 less than, remember that's a reverse. Less than is a reverse. So instead of 26 minus, it's something minus 26. Okay, 10 times the third, so 10, elephant butt. Well, elephant butt anyway, just because it's third, but not because it's a sum. The third is n plus 2. All right, so let's just read it one more time. 6 times the sum of the first and fourth is 26 less than 10 times the third. That's right, the third is n plus 2. Okay, so now I'm going to simplify and solve. Let's just combine these just because we can. So this is 2n. So now we're going to distribute this 6 not to the n and the n, but 6 to the 2n. So we'll get 12n. And then to the 3, so plus 18. equals 10n plus 20 minus 26. All right, so we need to combine these terms, so we get 12n plus 18 equals 10n minus 6. All right, get rid of the smaller variable term, which is this 10n, so let's subtract 10n from both sides. So we get 2n plus 18 equals negative 6. All right, so let's get rid of the constant on the variable side, so subtract 18. Okay, we're already at negative 6 and we're subtracting 18, so that means we're going to be at negative 24. Last step, divide by variable's coefficient. Divide by variable's coefficient. So n equals negative 12, but that's not our answer. We're asked to find 4 consecutive integers. Okay, if the first one's negative 12, what's the next one? It's not negative 13. It goes up, remember. So what's 1 added to negative 12? Negative 11, negative 10, and then negative 9. Oops, that was weird. All right, let's see if that makes sense. Let's plug it in. 6 times the sum of the first and fourth. Well, the sum of the first and fourth is, let's see, negative 21. So that's, I'm not going to circle that. That's confusing. The sum of the first and fourth is 26 less than 10 times the third. The sum of the first and fourth is 26 less than 10 times the third. So 10 times the third is negative 100. 26 less than, oh wait, 10 times the third. So yeah, negative 100. 26 less than 10 times the third. Oh, what did I do? Oh, 6 times the sum of the first and fourth. So 6 times that would be negative 126. And then 10 times the third is negative 100. 26 less than negative 100 is negative 126. Check, it works. Okay, that's all I got. Good job.
Flack.